Today we're going to talk about fractals. We plan to explore this concept through an object called the Menger sponge, seen here. The Menger sponge is essentially a cube that consists of holes at the center of each face of subdivided cubes from the original cube. This is created through iteration or recursion, where a cube is essentially divided into 27 subcubes, and the center cube just keeps on getting removed in an infinite process, creating a fractal, or an object or shape that has a fractional dimension, generally containing infinitely complex and never-ending patterns, which would be seen through these never-ending holes in this Menger sponge. But how can an object exist in fractional dimensions? It essentially boils down to a scaling factor, which is a number of sub-objects in dimension, and the number of sub-objects produced is equal to the scaling factor raised to the power of the dimension. When you scale a two-dimensional object by some factor, the mass is scaled by the factor raised to the second power. Here with fractal objects, you have a fractional dimension that the mass would be scaled to in any case of scaling that object. In essence, you have dimension through scaling. Self-similar objects are a certain type of fractals where you have shapes that give a basis for modeling the regularity in some forms of roughness. These self-similar objects have fractals as scaled-down versions of itself. And these concepts are useful in graphics as a way to represent rough images and create these complex visual images that occur and exist in real life today.